Okay, we are official. We are live. Okay, so today, this is one little thing that I neglected to teach when we were working on equations and graphing and whatever. And it's because of the way I teach, I tend to sort of be fluid and kind of go where I think I want to go and where I think you guys are ready to go. And sometimes I go with the flow, and sometimes I don't like to, I don't limit myself to books. And so every now and then something gets a little bit out of order. That's okay. This is out of order, but it's okay because it's useful, and you will be using it a lot this year. So a lot of times you're given 2 points. You know what a point is, right? A coordinate point. Or an ordered pair is another way you'd call that. Where you have a parenthesis, you have an X and a comma and a Y, and then a parenthesis, right? So that is a point. The X is usually a number and the Y is usually a number, right? Sometimes you're given 2 points, and you're asked to find the slope of the line that connects those 2 points. I have 1 point here, and I have 1 point here. Find that slope of that line when I draw a straight line between those 2 points. Now, if you were doing it with graphing, I can show you that way first. It's really easy. I mean, like with graphing, let's see, I should be using that graph because it would be easier, but I'll just try this. Hopefully it'll work. I'll just be really obvious. I'll make them really big so that it's not so hard to see. Okay. That way. Okay, so let's say I had this point right here, and let's say I had this point right here. Okay, so we can tell what that is. What is this point?
4, 5.
1.
Over 5.
You go over 1.
Actually, no, 4.
1, 2, 3, 4, right? It's 1 comma 4. So this is 1 comma 4. What is this point? 4 comma 1. Okay, 4 comma 1. Now, if I drew a line, through those points, I want to know what the slope is. Well, one way is to create a right triangle. Just bring this down as far as it goes until it's time to go this way, right? Now, I want to find this from here to here. Does that make sense? I want to find the length of this to this, and then I want to find the length of this to this, right? Make sense? So the way to find this length from here to here is I take, now everybody has to look at me for a second. Everybody has to be looking up here. To find, can you see me? Can you see okay? Can you see where my fingers are, Henry? Okay, good. To find the distance from here to here, you take the distance from here all the way up to here, and then you subtract from that the distance from here all the way to there. Does that make sense? If I take this distance from here to here, and I subtract this little teeny distance right here, I will have this distance here. Does that make sense? So, from here to here is 4. Would you agree with me? I rise 4. But from here to here is 1. So I subtract. So it's 4 minus 1, which is equal to 3. So I know that my slope, the rise, is a negative. To go from here to here, I have to go down 3. Does that make sense? So that's a negative 3. Does that make sense? Because remember, rise over run, it's a negative rise, so it'll bring me down. It's coming down. So my slope in this case is going to be something over something. It's going to be negative 3 over, now I have to figure out this distance from here to here. So I go from here, I'm assuming this is on this, that should be on level with this, sorry. But I go from here all the way to here, which is 4, right? And then subtract from here to here, which is 1. Oh, so we have the same thing again. 3. So but this now it's positive, so it's 3. So my slope is negative 3 over 3, which is the same as negative 1. right? So, but do you see how I subtracted? I took the total distance and then I subtracted this little distance. I took the total distance and I subtracted this little distance, right? Okay. So that's how you would do it on a graph. Yes, Noah.
So wait, why would you put a space between the line of the triangle and like the y?
You mean like why didn't I just bring this all the way down?
Yeah, and then all the way to
Because
the
this point didn't come all the way down. I'm trying to go from this point to this point, right? And so really, now, so I'm showing you sort of algebraically what I'm doing here, but I wouldn't even need to do what I did. I could just go, okay, to go from here to here, I have to go down, right? I could say, okay, down 1, down 2, down 3. So negative 3 over 1 over 2 over 3. Negative 3 over 3. See what I'm saying? I can always use a graph to find my slope. Yes?
So basically all you really have to do to find the slope is you have to subtract the first from the second. And so that would get 3, and then you add the 2, 3 together to find out how long your slope is. So then your slope is 6. 6 what inches? Or?
Wait, 6? No, your slope is this. Your slope is rise, which is negative 3, and then run, which is 3. So negative 3 over 3, this is your slope, negative 1. Okay? So if I was going to do another one, let's say I was going to do this. Let's say from here, let's use a different color there. Let's say I'm going from, I need a more dramatically different color. Orange! That's dramatic. Let's say I'm going now from orange here down to here. Okay? So now suddenly look at this. I'm going to have a straight line, boom, and I'm going to have a straight line down to here now. There's my triangle. So I'm going to actually, you always start with the left point and you go to the right point to find your slope, right? Notice, starting on the left point, I have to go up, right? So it's a positive rise. It's going to be a positive slope. Positive slopes always go up like this. Negative slopes always go down like this. That's a negative slope. It's going down to the right. This is going up to the right. It's going to be a positive slope, right? So now I got to just figure out, okay, how far? It's rise over run. Slope is rise over run. So then how do I do it? I rise how many? Well, let's see what that is. If I rose up to here, that is rising 1, 2, 3, 4. I rise 4, so I rise 4. That's 4 right there. And then I run, I don't know what it is, 1, 2, 3, 4. 4. Well, I keep getting the same ones, don't I? So my slope is 4 over 4. I rise 4 and run 4, which simplified, that fraction is just 1, or 1 over 1.
And that's the slope.
I rise 1, run 1. I could rise 1, run 1, boom. 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 See what I mean? So you can always simplify a slope into 1.
Oh,
so
and if you don't simplify a slope, the slope's going to be different.
It'll look different. But 1/2 is the same as 2/4, which is the same as 3/6, which is the same as 10/20, which is the same as 100 200ths, which is the same as 1,000,000 2,000,000ths. If you feel like graphing that far, go ahead. If you want to do 1,000,000 this way and 1,000,000 that way, go for it. Right? But keeping it simple, simplifying a slope, if it's 2/4, it's better to write it as 1/2. Just like it's always better, you know, your teachers, whenever you're dealing with fractions, it's better to use, you know, simplify every fraction. Okay, so that's how you do it with graphing. Now let's look at how you do it. This is the hard way. I mean, it's easy if you have a graph and it's already on the graph. But if you don't, you know, you have to draw the graph, and you have to draw it really well, and you know, you might not have graph paper. So we need to look at another way to do this, which is algebraically, okay? And so this is the formula. It's called the slope formula. It is not, I repeat, it is not the point slope formula. It is totally different than the point slope formula. It's just the slope formula. You notice the difference? You're missing a point, right? It doesn't have point in that, so it's just slope formula, right? I'm emphasizing this because everybody gets them confused.
They're all
right?
too similar.
Oh, it's horrible. Okay, so this is the formula. It says M stands for slope, mountain slope, equals a triangle y over a triangle x. Triangle is it's a Greek term. It's called delta if you said it, delta y over delta x. But the way I say it is what delta means. A triangle in math means the change in. So the change in y over the change in x. And change always means subtract. Always. You guys hear that? Change always means you're subtracting. So when I say the change in y, it means I'm subtracting y's. I'm subtracting two y's from each other. One y from another y. When I say the change in x, it means I'm subtracting one x from another x. Okay? Is that clear? Always change means subtract. If I wake up this morning and it's 0 degrees, and then I finish teaching math and it's 100 degrees, what's the change in temperature? 100 degrees. 100 minus 0. See what I'm saying? You always subtract. The change is a subtract. Okay, so this is the formula I usually use. That's the one I memorize and I use. Well, I memorize this too. But some people, for some reason, need to make it complicated, and they need this formula. And if you're one of those people that just needs to make it complicated, feel free to use this formula. It works. This is so much easier. But this just means subtract the y's and subtract the x's.
Wait,
right?
they're two
This
different
means
formulas?
subtract the y's and subtract the x's. They mean the same thing. Right? Now, if I gave you 2 points, 2, we'll try this. We'll go 2, 6 and 5, 1. Okay? And I'm asking you to find the slope between these 2 points. All right. I can make this x1 and this y1. And then if I did that, I'd have to make this x2 and this y2. But the cool thing is it doesn't matter which one you make which. You can make this x2 and y2. If this is 2, this has got to be 2, right? I mean, if this is x2, this is going to be y2. You can't do x2, y1. You can't do that. You can't mix them like that. You can't do x1, y2. You can't do that. It's got to be x2, y2, x1, y1, or x1, y1, x2, y2, right? You get that? So it doesn't matter which one you start with. I like to start with the bigger y. That's just my policy, the way I do it for myself. That way I'm more likely to deal with a positive number than a negative number. So which is my bigger y? What are my y? This is my x, and this is my y. This is my x, and this is my y. Which is my bigger y?
Left one.
This one, right? That is bigger. So I'm going to make that my 2, and the x my 2. I'm going to make this my 1, this my 1. Now, I'm doing it right now using this method, and then I'm going to show you how I use this method, okay? This is so much easier. But it's the same thing, really. It's just there's a lot of 2's and 1's in this one, right? You don't have to memorize all that stuff. But, so if I did this and followed this formula exactly, it'd be m is equal to y, I'm going to just write the formula again, y2 minus y1 over x2 minus x1. Notice the y's are up high. Y's fly, right? The x marks the spot on the ground, right, where the treasure is. But the y's fly, right? So y's are always on top. That's really important. That's the biggest problem that people have with these. They often put the x's on the top and the y's on the bottom. Don't do that. Y's fly, okay? So m is equal to that. So now my y2 is 6. I put a 6. And then the formula says minus. So I got to put a minus. And then my y1, my y1 is 1. And then I put a line. And then I have my x2 is 2. And then, yeah. And then minus, because the formula has a minus sign. And then x1. x1 is 5. All right. Now let's see what that is. What's 6 minus 5? 6 minus 1?
5.
5. over, what is 2 minus 5? Negative 3. That tells me the slope is negative 5/3. That tells me it's actually going down to the right because it's negative, right? That wasn't so hard, was it? That's pretty easy. Okay, let's do another one. Okay, let's try another one. What time is it? Okay, let's try another one. I'm going to make it a little harder. We're going to have negative 5, 8 and 2, negative 10. Okay? You writing this down? Be sure you write them down. It'll make a big difference. So I am going to, again, figure out which one has the bigger y.
2, wait, no, 5,
Negative
8.
5.
That has the bigger y. That's the one I'm going to start with. Sometimes when I figure out the one I'm going to start with, I'll go like that. All right, that'll help you with the other method. But so negative 5. So this is my x2 and this is my y2. This is my x1 and my y1. In the beginning, if you're going to use this method, I suggest you do this. Put the x1 and x2, y2 and x1, y1. It really does help if you use this method. So again, it's y2 minus y1 over x2 minus x1. A great way to memorize a formula is to always write the formula first before you actually solve the problem. That way, every time you're getting your brain, you're teaching your body to know the formula, right? It really works. So y2 is 8. And then the formula has a minus sign. Don't leave yet. The formula has a minus sign. And then it says y1. y1 is negative 10. I don't just put 10 here because I already put the negative. This formula has the negative in it and the point has the negative in it. I have 2 negatives. Right? You see that? That's really critical. You see that? So what's negative negative mean?
Positive.
Positive, so I'm going to turn that to a plus. All over, now I have x2, negative 5, and then minus, the formula has a minus, and then x1 is a positive 2. All right, so what's my answer? What is 8 plus 10?
18.
18. What is negative 5 minus 2?
Negative 7.
Negative 7. So my slope is negative 18/7. I can't simplify that anymore as a fraction, right? Does that make sense? It's not hard. So then tomorrow I'm going to show you how I use this method, okay? But that's what I want. This is what I want you to do tonight, and I'm going to turn this off and I'll give you the homework.